Welcome back, everyone. I'm Steve.
And I'm Scott.
Together, we're Backyard Musings, broadcasting live Apple Valley.
Strictly science and technology with a little bit of politic.
Did you get the red memo today? Because Scott did.
Guess I did.
Yes, the red memo.
First shot I grabbed.
We don't coordinate.
We are uncoordinated in everything we do.
And did you know that Scott and I are 10th cousins once removed?
We are, yeah.
Good grandparents.
On my dad's side, yeah. My dad's side through my dad's mom, my grandmother. So
Yeah.
Interesting.
Yes, very interesting. And we found that out through Family Search. You can
Yeah.
put your device next to each other and look for relatives around you, and boom, it pops up.
Yeah.
Like a genealogy thing.
It's very, very cool device.
Yeah.
Very cool app.
Okay, Radiant, a startup based in California, has raised $165 million in Series C funding. This funding will help the U.S. modernize its energy systems by developing portable nuclear microreactors. You heard that right, portable and micro, using advanced nuclear technology. The announcement, made on June 2nd, pushes Radiant's total venture capital raised to $225 million, reinforcing its ambition to bring mass-produced 1 megawatt microreactors to market by the decade's end. As demand for resilient energy grows amid rising global instability and climate volatility, microreactors may emerge as vital assets in the next evolution of nuclear power. Would you like to know more?
Yeah, and we've talked about these things before, right? The little where they may have them for tracks of homes or
right off the assembly line.
Yeah,
put them in
houses,
forward operating bases for the military.
Yeah, exactly. This is pretty cool stuff. The round was led by DCVC, Data Collective Venture Capital, with participation from a range of new and returning investors, including Stepstone, Giant Ventures, Hanwha Asset Management Venture Fund, SGA, Crossbeam Venture Partners, ARK or ARC Venture Fund, Align Ventures, Heartbeat Ventures, Gigascale Capital, and Pax Ventures. This infusion of capital arrives at a pivotal moment for Radiant, following the U.S. Department of Energy's recent decision to supply the company with a high-assay, low-enriched uranium, HALEU, or HALEU. Are we going to call that HALEU or HALEU?
HALEU.
For its first operational reactor tests. So
I'll tell you what's driving this is AI. AI has a huge power requirement, right? And
so I don't know enough about that to ask why.
Yeah, all the big players like Google and Meta and Amazon,
all the bad guys
that have AI. It really takes a lot of power to power up the AI. Any questions or any write this paper for me,
Yeah, exactly.
And so the data centers are needing that too. So that's what's driving this.
Dumbing down the masses. So, but anyway.
The reactor, known as Kaleidos, is a 1 megawatt microreactor engineered for modularity, rapid deployment, and diesel generator replacement. Its use, diesel generators are pretty cheap. So are these microreactors going to be cheap?
Well, I guess we'll see.
Its use cases, and another point is, it's got enriched uranium in it, or some kind of uranium. Wouldn't that be vulnerable?
It's nuclear, right?
Yeah, wouldn't that be vulnerable to people coming in and stealing the uranium to make dirty bombs? You're going to have to secure this.
Yeah,
I don't think so. Its use cases target austere environments, remote settlements, military forward operating bases, and disaster zones where grid infrastructure is absent or compromised. Radiant is one of just 5 U.S. companies selected to receive HALEU under the DOE Strategic Enrichment Program, reflecting growing federal support for next-gen civilian and defense-related nuclear platforms.
The first Kaleidos prototype is scheduled for live testing in 2026 at the Idaho National Laboratories DOME, Demonstration of Microreactor Experiments facility. Quote, adding some of the smartest minds in technology investment to our team is a powerful vote of confidence in Radiant and the belief that America must continue to lead in nuclear innovation, says Doug Bernauer, Radiant's CEO and a former SpaceX engineer. Go on with the quote. We are ramping up to test the first 5 reactor designs in the U.S. in over 50 years.
My father-in-law worked at Idaho nuclear lab.
Really?
Yeah, retired from there.
Cool.
Radiant's reactor is based on a helium gas-cooled design with passive safety architecture and no reliance on water for cooling. What? Let's read that again. On a helium gas-cooled design with passive safety architecture and no reliance on water, offering survivability in harsh environments and reduced logistical burden.
Wow.
I'll buy that for $1. The system is designed for air, road, or sea transport and includes an integrated power conversion unit and modular shielding.
The company projects an output of up to 50 units per year once its production facilities are operational. Site selection and early construction planning for these manufacturing facilities are underway and will be funded using proceeds from the Series C round. Industry analysts view Kaleidos as a key player in the emerging field of tactical and off-grid nuclear energy and an area of strategic interest for national defense planners and climate-focused investors.
Quote, we are seeing a new nuclear renaissance play out, said Will Dufton, head of growth investments at Giant Ventures. Continuing the quote, Radiant's success will uncork the final bottlenecks to progress for the entire nuclear industry. Radiant's backers now include heavyweights such as Andreessen Horowitz, Union Square Ventures, Founders Fund, Chevron Technology Ventures, and Draper Associates.
Okay, founded in 2020, Radiant aims to deploy its first operational reactors to customers by 2028. Its mission is to produce the most economical, safe, and logistically flexible microreactors on the market, a vision increasingly aligned with U.S. national security, energy resilience, and climate imperatives.
So I got a little concerned about this. So let's say these are, the next best things to slice bread, and they start popping up all over the place. What if something happens where there's meltdowns, like a cascading effect or like a defect in the design, and you start having meltdowns, and then you're releasing the radiation in the atmosphere?
I don't know. Maybe they'll have to encase these things in some kind of a containment.
Once they get to their final location?
Yeah. You'll have to, depending on where they are. I mean, where are these things going to be? Military bases, right? Remote military bases.
Or any austere, like Greenland or Antarctica. Or, if they start to get popular, they could power cities, whole cities. You could see 3 or 4 of them in LA.
Yeah.
A couple in San Diego, one in San Francisco.
Yeah. I think that's going to be down the road.
One out
and
here.
Again, that's going to be, any nuclear facility has that possibility, right? But we talked about it here not too long ago. There haven't been that many. Obviously, the ones that we think about are 3 Mile Island, Chernobyl. Those were Fukushima, yeah. Those were very, very bad. But how many nuclear facilities are there, and how long has nuclear power been being used? It's been decades.
Yeah,
and
it is.
We just
50 years. Yeah.
Again, not trying to simplify it, but there are car accidents every day. People die in car accidents every day. Your fault, my fault, nobody's fault. They're not banning cars. So, planes crash. They're not banning planes. So it's
people die from guns and they're banning guns.
Well, yeah, but that's, again, we both know that a gun can't pick up off of a table or out of a safe or off of in a drawer and shoot somebody. It has to have
human interaction.
Yeah.
Trigger.
Lame mind syndrome. Somebody has to do that act on it. So, but yeah, but it's cool. And I think if they started off in a remote situation, military facility,
they're always the guinea pigs, the military.
Yeah, and they're gonna and the mice.
And the mice, yeah.
So,
but social experiments, same-sex marriages, military.
Right. But so let's try it, and hopefully these guys are working. I'm sure the minds that are behind all this are thinking about all that kind of stuff. So
a great, end state, a great idea. I just hope if they can be secure and not melt down,
Right.
So
and no need for water. So obviously they're cooling it with helium,
yeah.
which that's maybe that's what they could eventually do in the larger facilities.
Yeah. Yeah. All right,
So,
folks, tell us what you think. We want to know what you think. And
yeah.
got some great comments coming in. We're starting to build up our, you guys are the faithful beginners with us.
Yeah, we really appreciate the people that are subscribing and the ones that leave comments. And yeah,
there's hope for science and technology, right? And we got these people listening.
Yeah, it's fun.
All right, thanks for joining us.
Take care, everyone.
That's right there.